Disclaimer: the video is for educational purposes only. I do not endorse the abuse of games of any kind. The bot will remain private and will not be used. AI is gonna steal our jobs, right? Lucky me, I don't have one. Hello guys, today I woke up with a thirst for knowledge. So I thought about learning how to detect objects in images. Isn't that what we all usually do? Or is just me? In this episode I will tackle some topics that might be a bit more complex for beginners, but don't you worry, I might explain them better in future tutorials. I searched for information on how to use AI to detect things in images, but I could not find anything good, either in English or Romanian. After a few hours of struggling with Google, I finally found a page. But it was in Chinese. The problem is that, you see, I don't know if you're aware, but I don't speak Chinese. I can barely speak English, let alone Chinese. So I used my super powerful, extraordinary tool, Google Translate. I entered what I needed to be translated, hit translate, but it gave me something about cheese and I gave up. Luckily, there were also images and I managed to figure out what I needed to use. I felt like I was stealing information from the Chinese government, like an undercover spy, a hacker. But at least now we are square for that stolen Steam account. I will find you. I found two methods to detect things in images. The first one was straightforward. I just had to give it a small picture of the object I wanted to be detected, and it would detect it. However, the object had to look identical to the picture I provided. Otherwise, it would not see it. If it looks slightly different, it could not see it. This wasn't great because in games, the object could look a little bit different depending on the weather, the time of day, location, or the angle you look at it. But played around with this method for a bit. Gave it random pictures of objects to look at, but it didn't work well. And it was also extremely slow. And then there's this picture. Well, I can't say it doesn't see because it does. It sees everything, nothing escapes his attention. The second method was more complicated because I had to train it first. I could not just give it a picture and be done with it. However, it gave the best results. It was very fast. Once I optimized the code, it could reach 60 frames per second. Default, with no training from me and without optimizations, it could detect faces in images at around 20-30 frames per second, with high resolution. But I'm not the Chinese government, so I don't need to detect faces. I chose to make the bot work for the game Albion Online, a game similar to Metin or World of Warcraft, but newer. I chose this game because that's what I was playing at that time, when I created the bot. After I almost finished the bot, I found out that there's a big problem with bots in the game, and the game developers were trying to get rid of them. Well, fuck. I'm apparently contributing to the problem, but it wasn't my fault. I did it for science. Also, I keep the bot private to prevent it from falling into the wrong hands, so I hope it's okay. I chose to make the bot capable of fishing because I thought it was one of the easiest things to teach. Of course, theoretically it could be trained to do anything in any game, even play Valorant, but it will take way too much time to train. Fishing in this game works like this. You equip a fishing rod and you hold down the click in the direction where you want to throw the hook. The longer you hold click, the further the hook goes. When you catch a fish, larger waves appear in the hook area. After that, you click again and the minigame starts. We will teach the AI to recognize those waves, to know when the fish is biting. In the minigame, you must not let the hook go too far to the left or to the right for a certain duration, or you will lose the fish. So, the bot needs to decide when to click and release the click, based on what it sees on the screen. It needs to learn how does it look when you catch a fish, and how the hook looks in the minigame. So I started training it. It involves giving it hundreds or thousands of pictures of how it looks when a fish bites the hook, and images when the fish does not bite, images with the hook in the minigame, and images without the hook in the minigame. It compares these two sets of images to find a common difference in the picture, and that difference is the object it needs to detect. It's more complex than this, and there are various methods to do it, but that's the basic idea. You have to train it separately for each object you want it to detect, and for each object it will give you a file containing information about how does that object look like. Before it can detect anything, first you have to load the file specifying details about the object you want it to detect. If I want the AI to detect when the fish is biting, I have to load the file with the information about how it looks when the fish is biting, so it knows what to look for. If I want it to look for the hook in the minigame, I have to give it a file about what the hook looks like in the minigame. Now you can imagine that I spent hours in the game going from one corner of the map to another, collecting images. It was like being a tourist, randomly taking screenshots, fishing a bit, taking more screenshots. It was like I was about to post them on Instagram with hashtags like #travel-life, #exploration, #you only live once. The bot doesn't save any images, it only uses them for training, and what it saves are things like lines, edges, squares, so there shouldn't be any copyright issues, I think. It's like looking at many pictures of a ball and then remembering that it's round. If you see something else round, you can say it's a ball. After each picture, I had to make it black and white. Each image had to be made black and white, and all of them had to have the same resolution. All of them. I spent a lot of time in Photoshop preparing them for training. Training takes a long time. I had my processor running at 100% for about 2 days while I was watching shows. Well, not really watching, more like I was looking at pictures from the shows because of the lag. 2 days for 2 objects, the hook and the fish bite animation. After that, I created a small test program where I could choose which file to use and then see if it works. And to my surprise, it did, thanks to the Chinese god who wrote about how this stuff works. I almost forgive them for stealing my Steam account. But I still had to press the buttons and clicks, and it couldn't interact with the game. Like a woman in the 1800s, it could see how the voting works, but it couldn't interact with the voting system. Now let's move to the next problem. How does the bot interact with the game? How do I simulate buttons and clicks? This part was actually quite simple because I used the user32DLL. For those who don't know what user32DLL is and what DLL files are in general, they are files that contain many useful functions that the Windows and other programs can use, and you can use them in your code. Imagine a library with lots of books on the shelves, where each book is a function that can be taken and used. I used the 32DLL to tell Windows where to click and which buttons to press, among other things. Now that I could simulate buttons and clicks and detect when the fish is biting and what the hook looks like in the minigame, I needed a way to record the screen and then use object detection on each frame, which means on each image from the recording. A recording is composed of several images that come one after the other, and that's where the term FPS, frames per second, comes from. How many pictures are displayed per second. While recording the screen, I can extract each image separately and make the AI look at the image to tell me if he sees something or not. C# has a common method for recording the screen, so I use that. Now that I have all the pieces separately, I needed to combine them. I'm not great at combinations, especially in the real world with humans, but luckily this is the virtual world. I followed that with a UI that looks decent. UI means how the application looks. Buttons, colors, shapes, text. And I had an idea. I call it leash design. I don't know if it already had another name or I invented it. Probably I didn't invent it. The bot's window sticks to the game window like a leash, and if I move the bot's window, the game window moves too. They are attached to each other. I won't lie, I spent quite some time making it work, but I think it was worth it because it looks interesting. I don't remember exactly what I used, probably still the user32DLL. Each window on the computer has a specific name. When the bot starts, it looks for a window with the game's name, and if it finds it, it saves a reference to it. If I move the bot window also moves the game window to the same location using the reference. Now let's talk about traits. We reach an experience level where we need to have this discussion. I know it's embarrassing, but it's normal, it's biological. Actually, it's technological. Traits are like workers. Each processor has a certain number of workers that can work on something at the same time. Every application uses workers to do their work. Each worker can jump from one application to another, just like the Flash. If he was working in construction, running from one building to another, and working in multiple places, one after another. The more threads you have active on your processor, the more of your processor capacity you use. Normally, an application gets only one worker. When it starts to take care of it, update the buttons, the screen, do various things, that worker is called the main thread because it's the main worker. Or it's also called the UI thread because it mainly takes care of the UI, the application window. Games usually have only one thread, but games like Minecraft might use multiple threads to load the world faster, by using a technique called multithreading. Many games and apps use this. You can call multiple workers to work on the same application or game at the same time to do a task faster. If you want to do something that takes, let's say, 5 seconds, and you only have one worker, that worker will start doing that thing that takes 5 seconds. And during that time, it can take care of buttons and other stuff. It will look like the application is frozen because that worker is busy doing that thing that takes 5 seconds. But here's the thing, you can call another worker to do that thing that takes 5 seconds, and the first worker can continue taking care of the application, like letting you click buttons, move windows. You might see when you're recording the screen at 60 frames per second while each frame is being processed by the artificial intelligence while it's making decisions about which buttons and clicks to be pressed and for how long. And all of this with just one worker. It can get overwhelming, and the application can appear to be frozen because there's just too much work for just one worker. And that poor worker can't even go on a strike to ask for a raise because he doesn't even get paid. So here's how the application works. There's the main thread, the worker that came with the application when it started. This worker calls another worker responsible for recording the screen. When the other worker finishes recording a frame, it sends the recorded frame back to the main thread. The main thread receives the frame, calls another worker, gives it the received frame, and this new worker takes care of object detection only on that specific frame. This means that the application calls about 60 workers per second, one for each frame, adds all the requests into a list because I don't have 60 available workers in the computer, maybe just around 16. And from those 16, the available ones will come and take some work from that list. This means that a maximum of 16 workers can process frames at once. I say a maximum of 16 because not all 16 are available. I have other applications in the computer that also use some of those 16. Maybe each worker manages to process 2 or 3 frames per second. Probably won't manage to process all the frames, but enough to have about 40 to 60 frames processed per second with the CPU at 100%. After object detection, the information goes back to the main thread, which runs the code for the selected behavior. You can select between multiple behaviors, but only one is added, the one with the fishing. Each behavior comes with its own little menu in the bottom right and its own logic. The main thread, the worker that came with the application, takes care of the application interface, buttons, and the selected behaviors code because it doesn't consume that much. Each behavior is separated from the rest of the application. This means that I can add other behaviors, each one with its own little menu in the application, and each one with its own little logic. And I don't have to edit anything else, I just mark the behavior as selected. The information from the object detection goes to the selected behavior, whatever it is. Everything remains pretty much the same. Recording stays the same, object detection stays pretty much the same. The only difference is the selected behavior and what the selected behavior does with the received information. In a way, it's like having the same eyes, but your brain changes. The fishing behavior was like this. The player chooses for location where the bot can fish. Every time a frame is processed by the worker responsible for object detection, runs an execute function on the selected behavior, a function that all behaviors have. Each behavior does something different when the execute function is called, depending on what stage the behavior is in. For example, in fishing there are stages like throw hook, wait for bite, and play minigame. Depending on the stage, the behavior decides what to do when the execute function is called. In the throw hook stage, it runs the code for throwing the hook at one of the 4 specified locations on the screen. It waits for a few seconds for the in-game animation to finish. Then it changes the recording location so the bot records only a small area around those 4 points. It changes the object detection file to the one it received during the training to detect when the fish is biting. Now that it has thrown the hook, it changes the stage to waiting for bite, and it runs the code for this stage. In this stage, it uses the information from the object detection to check if it detected the fishing bite animation. Because I didn't train it very well, sometimes it hallucinates things. So I added the rule that if it sees something, it must see it for at least 40 times in a row for it to count, otherwise it ignores it. If it sees the fishing bite animation 40 times in a row, it changes the recording location on the screen to where the minigame is displayed. It changes the object detection file to the one it receives during the training to detect the hook in the minigame, and it changes the stage to playing minigame. In the next run of the execute function, the stage is playing minigame, and it runs the code for playing the minigame, in which it takes the coordinate from the image where it detected the object. If the location is too far to the left, it holds click to move the hook more to the right. And if it's too far to the right, it releases the click to move the hook more to the left. It repeats this process until the bot no longer sees the hook on the screen for 40 times in a row, which means that the minigame is over. It adds a 1-second delay to allow the in-game animation to finish, and it changes the behavior back to throwing hook to start over. And that's how it works. It can fish for me. It doesn't fish perfectly. Sometimes it gets confused, but it can do it. I could teach it to gather materials from the map by adding another behavior. First, I have to teach it how each material looks like and then add a new behavior with many stages. It will start with a random walk stage where it wanders randomly on the map. If it sees a resource, then it changes to gather material stage. In this stage, it will go to the location on the map where it saw the materials and click on it. When the material is close, it clicks on it again to pick it up and then it goes back to random work stage. But that's the end of the project. I'll keep it private for my CV and I might improve it at some point. Many other projects are coming to the channel, so don't forget to subscribe.